Good morning. I would like to welcome everyone on our first webinar from the series Optical Analysis in Ansys. My name is Marcelina Jureczek and I'm Head of Marketing in Mysco. Today we had a special guest who prepared the presentation for us. I would like to welcome David Golembowski, who is optics expert from Ansys, and Michał Ziemba, who is CTO from Skanway and who will share with us their case study.
So, what is our plan for today for the next 2 hours? We have an attractive, long agenda. For today, we like to introduce all of you who is Ansys. We like to discuss with you, we like to introduce you what is our understanding about optical design challenges and how we are providing Ansys solutions. We like to introduce you about our software solutions. What is numerical, what is Emacs, what is BIOS, but also thermal desktop and optics. Because these first 3 chapters are building the base for chapter number 4, where we are showing very roughly and quickly a multiphysics workflow on CubeSat satellite mission. And with chapter 4, we are very proud to give Skanway the stage for today's webinar session to introduce from their side as trustful long-term customer with Ansys how exactly the portfolio we are providing on a multiphysics level for optics design and optics validation in critical environments are used to ensure product performance. Afterwards, chapter number 6, 7, 8, we are talking about specialized Ansys startup program. We are talking about Ansys academics for teaching, for research, but also how students can have free access to some software solutions. And in chapter number 8, it's the networking. We are discussing where you can find, or we are showing you where you can find informations and where you can start individual self-paced training to understand and to increase the usage of our software solutions. Chapter number 9, question answering. Please put your question into the chat. And if we have more or less time, we will discuss these chats at the end of the session. If we are running out of time, we will give you a response over the next days. Okay? So, and now let's start about Ansys generally. Maybe one of you or some of you are not knowing who's Ansys. Okay? Ansys is a software provider. It's a leading software provider for multiphysics software solutions to provide a virtual prototyping on a nominal design, but also on a multiphysics edge case scenario test. We are providing the software solutions since more than 50 years. We are a US-based company. Our headquarters is in Canonsburg, and we are only focused on simulation. That's all we are doing. And for that, we are providing a complete team of more than 6,000 employees globally, split it in more than 90 offices worldwide, in North America, in South America, in Asia, in Europe, in Australia, in Africa. Everywhere, we are providing our solutions for economical and technical success on virtual prototyping. We are strong on the market. In 2024, we made a revenue of more than $2 billion US. So that means we are a very powerful partner and trustful partner for all our clients. And this is especially my job. We are focused on customer satisfaction. Our solutions, our software needs to reach your goals on academics and on commercial. And me, as a product specialist, staying close in communication with Mysco, how we can find, how we can create positive business outcomes for your goals, to reach your goals in cooperation with Ansys and Mysco. So, as introduced, Ansys is providing software solutions on a multiphysics level to provide a virtual prototyping. And for that, it is mandatory not to look only on optics. We are needing to look on electronics, fluid simulation, safety and code security, semiconductors, cloud systems, HPC, GPU performance, using graphic cards to speed up the simulation. We are providing simulation for mechanical stress analysis. We are providing simulation for particle flows and mission engineering. That means from a design of a pure sphere up to the validation of a space satellite in outer space, we are providing all needed software solutions. And all our software solutions can be linked to each other on a multiphysics level. But for today, we stay focused on the optics. We are looking on a nanoscale technology tool, we are looking on an optical design tool, and we are looking on a system tool to reach from a nanoscale design to a complete system validation in edge case use cases. So, and what are now the challenges? If you are working as an optical engineer, if you're working as a photonics engineer, or if you will start thinking as a student to become an optical photonics engineer, you will have different challenges. But you have also the advantage, looking on optics, looking on photonics. This technology is everywhere. Everywhere you're touching a product, mostly optics is inside. You can look on outer space engineering. You can look on telescopes design. You can look on, daily use glasses, smartphones, rocket technologies, augmented reality glasses, medical devices, cameras, fiber coupling, sensors on industrial production lines, automotive lighting, autonomous driving, head-up displays, cockpit lights, satellite communication, microscopes, laser pointers, space observation. All the topics are needing optics, and the usage of optics photonics is increasing massively. If you have thinking about a new job as a student, starting on optics photonics, you're welcome. The market is searching for you and needing research partners to deal with new technologies. So stay focused if you like to start your job as an optical engineer. If you will start, or if you're working as an optical engineer, you are knowing, or you will come to some simple known challenges. As an optical engineer, you have to achieve a product by different points of views. You need to care as an optical engineer. We know that our customers needing to know to design high precision optics. They are needing to care about aberrations and image quality. They are needing to care about the right solution or materials or material selections and their properties, performance, costs. They are needing to validate optical designs against thermal environment factors. You are needing to make complete optical simulation modeling from component optomechanical systems. You are needing to miniaturize your optical system in new designs and new packages. And you have to respect, for sure, the manufacturing of your optical lens system to stay clear and robust in the tolerances. And for sure, for each development, the costs and timing of a new product or an optimizing of an existing product is mandatory to track, because a product needs to be fast on the market to increase the business outcome of it. But it also needs to be fast and accurate in the market. And all these challenges needing to respect the optical design. And this can be on automotive, on consumer electronics, space observation, or data communication. All the technologies having the same challenges. If you're talking about optics at Ansys, we're generally talking about a specialized wavelength spectrum to find a separation to electromagnetics to high frequency. On optics and photonics, we are talking about infrared, visible light, and ultraviolet range. From roughly round about 100 nanometers up to 100 micrometers, we are talking about optics as a physics-based simulation, looking on a component. And all that simulation tools we can add each other to look on the system and measure also performance of an optical design in our optical tools of working inside the systems, in a virtual prototyping, in edge case and weather conditions. For that, looking on the wavelength spectrum, we are providing 3 fundamental software solutions. From a first nanoscale solution called Ansys numerical, we are providing a photonics tool. A photonics tool which is using the Maxwell equation to simulate the transport and the behavior of radiation with respect of the wave behavior. So maybe knowing, looking on light, looking on radiation, you can validate it against as a particle or the wavelengths, or the wave. And especially if you're talking about nanoscale designs, where designs are equal to the wavelengths of interest or close to the wavelengths of interest, you're needing to respect the wave behavior of radiation to design nanoscaled plasmonic patterns, to design waveguides, sensors, RGB displays for smartphones, anti-reflex coatings. All that stuff, we are needing to respect an FDTD solver to validate specialized optical elements like diffraction. We like to detect and we like to use these effects on such a tool. All on nanoscale technologies, we are providing the Ansys numerical. Next step, from a FDTD solver to a ray tracing solver, which is simulating light radiation as a vector, hitting a surface, which will be absorbed, transmitted, or reflected. We are providing the Ansys CMix. The Ansys CMix is a tool which is focused on optical design, camera lens system, but not only an optical design of a simple lens, a lens stack full of freeform lenses. It's not only the design, it's also the optimization, analysis of tolerances by the lens itself, but also on the optomechanical systems to provide a manufacturable product and a product which is good for the tooling, matching with the tooling, and providing the customer performance. Last but not least, we have the Ansys SPSM. SPSM is a lighting tool and system tool. This tool is also a ray tracing solver like CMAX, looking on a particle which hits a surface, but it's focused on lighting technologies. This design of optics are a little bit more simple. We are using freeform reflectors, ellipsoid reflectors. We are using light guides. We are using pillows on optics to spread the light, which is mostly used in automotive and general lighting. The advantage of SPSM is that it is also a system engineering tool. That means you can put your Ansys numerical information, for example, in nanoscale meta lens design, you can put it into an optics design of CMAX, and in SPSM, we can validate the complete system. How the system works, how the sensor performance looks like under critical ambient conditions. And all that stuff, all that three fundamental solutions are able to matching the need on a component design depending to the industrial usage of our customers or to the system responsibility of our customers. That means we have a very valuable bridge we can close with our portfolio. We can build a bridge at Ansys, only at Ansys, to provide a nanoscale photonics FDTD design into a Monte Carlo ray tracing solver like SPSM and CMix. That means we can design nanoscale plasmonic patterns in numerical. We can transfer the near field information of that simulation into our CMix and into our SPSM to validate how a nanoscale design has an effect of readability and on contrast, for example, of a head-up display. We can design optical coatings in numerical, interference coatings, anti-reflex, high reflex. And then we can transfer the coating information as a library material into SPSM, into CMix to validate the performance and to look on the rest reflex by a visualization. We can design new emitters. We can design LEDs, micro LEDs. We can design in the next releases also pixel designs. We provide sensor technology, sensor designs in the visible range, in the infrared range for cameras, for thermal cameras, or infrared cameras. We are providing display technologies to simulate the readability and the effects of polarizations for new smartphone technologies or screens generally. Or we can create VDF materials in numerical to decrease the reflection of displays, which cares about customer-like products in automotive or on a screen for TV, for example. So, and this is unique. This bridge between nanoscale design and macroscale designs and macroscale system validation is unique at Ansys. That means working with Ansys Optics means for each of our customers and each of their engineers using advanced simulation. Why? Advanced simulation? Because we are providing multi-physics integration. We can use our Ansys Optics to predict how an optical systems is working after multi-physics effects like thermal heatings and mechanical stress. We can provide visualization, real physics-based visualization. That means we can predict to 99% how that product looks like and where is the weakness of a product. We are providing GPU capability. We are providing HPC capability. Looking on complex designs, GPU, HPC, cloud systems are mandatory to decrease the simulation time to a minimum. We have a faultless data transfer, as discussed at the one slide before, between FDD solver and Monte Carlo ray tracing solver. And for sure, our Ansys Optics bundles having a full integration into the complete Ansys ecosystems to mix it with the mechanical simulation, to mix it with the fluid simulation. So, and for that portfolio, 3 tools for one solution: optical design, respective photonics design. You will have, or you are knowing, different challenges, and some of them we like to discuss with you. One of the biggest challenge looking on optical design, as discussed in some slides before, is the complexity. The complexity of design and standards and materials. You have to balance the materials, the geometries, the respect of wavelengths. You have to edit in optomechanical tubes, and you have to validate and to reach a specialized saved performance. And today, most of the usage, most of software users are using disconnected tools, using uncoordinated disconnected tools. Looking on product prediction, how a product works in real life by virtual solutions, because products in a nominal design can be very different against edge case scenarios, environmental factors like sun, weather, pressure, temperature. And the current state is that many solutions are not considering the complexity of such operations. And last but not least, one of the biggest challenges are the time and the costs. As slower the engineering time is, as later you are on the market, as much you are losing the unique state-of-the-art solution. And costs of prototyping can crash a complete budget of a project, because prototypes can cost up to millions, especially on space, testing on different environments. That means time and cost prototyping needs a complete testing and prototyping with expensive materials, expensive tooling, and having a long time to delivery. If you're building a real prototyping, you have to set the right weather conditions, the ambient conditions, all that stuff, all that steps needing time and money. And at this moment, many customers or many companies not using the full multi-physics workflow of simulation to predict the optical performance of a system under environment conditions by virtual prototyping. And they are spending a lot of money for real prototypings, which can be saved by virtual solutions. So, and now let's take a look on the Ansys environment of a complexity of design. As you know, you have to balance materials, technologies. And looking, for example, on augmented reality glasses, we can provide at Ansys the bridge from photonics to optics to multiphysics and GPU, because designing an augmented reality glasses is needing nanoscale diffraction ratings. It's needing a ray tracing solver to simulate the optical projection coming from the camera. Needed to protect it on multiphysics level. That's augmented. The AR glasses are working under different scenarios under different weather conditions. We are able to use our tools for optimization, to reduce the package, to increase the performance. And we are providing the tool for the human vision rendering. That means you can look on the performance and you can validate how that customer like is accepted or not, how that images looks from different points of view and different focal points. And all that stuff is covered by GPU to make it quick, but also accurate and trustful. Looking on prediction, our tools are used to make management decisions. For example, for BMW, we catch great feedback that our solutions are providing information exactly like in the real life. That means on a management level, making decisions, virtual solutions helping to optimize designs and to predict a design under different edge case scenarios. This is focused on a seamless light interaction, means model optical behavior from nanoscale designs to large-scale optical systems, from a new light source to a complete light guide covered by the interior. Thermal and optomechanical modeling, how that light guide is changing or how the LED is changing under heating, how the color shift comes, where is the hotspot, where's the dark spots due to some manufacturing rules, how that looks like under a human eye view, respecting light, dark adjustment, respecting accommodation, respecting glare effect of different observer ages, how that product looks like for a 24-year-old boy and for a 65-year-old lady. All that stuff can be rendered real physics based by our solutions. And for sure, this virtual rendering helping our customers to reduce prototyping costs and to stay faster in the development. Here you see some examples. On the left side, you see an airplane cabin lighting perception to validate customer-like feeling of light color, light distribution, how it looks like. Customer likes it or not under different scenarios. Day fly, night fly. You can play with the materials, the color of the seats to validate which is the best performance, matching on performance and matching on quality. But also on the right side, automotive cockpit designs. Where is the display? What effects has the sun on the readability of a display? What quality is the light guide? Has the light guide from different points of view? What is the effect of interior cockpit materials and colors? What is the reflection of a windshield? All that stuff can be covered by optics solutions. So, and on time and cost of prototyping, the Ansys environment predicts a complete faultless transfer of technologies between FTDD, nanoscale FTDD server to macro-scaled ray tracing server. We are allowing our customers to make design variations quickly and accurate. And on a virtual prototyping, we can test each design under the edge case scenarios described in the RFQ, for example, weather condition, sun condition, temperature, pressure. And that means with Ansys Optics, we are delivering the most efficient way of virtual prototyping. And we are allowing our customers, especially on unique, new product designs, to stay fastest on the market. And these are key drivers we care about. Make you successful with your products on your market. So, and for that, now let's take a deeper look into our software solutions. You are knowing numerical, you are knowing ZMax, you are knowing SPSM. And what is numerical? As mentioned, numerical is a photonics design tool. Focus on nanoscale applications, but not only on component design, but also on nanoscale multiphysics design. Quantum efficiency, for example, important for solar cells, how a photon will be changed efficiently to an electron. All that stuff on a nanoscaled design is solved by numerical. Our key users from industry sites are aerospace and defense, automotive, communication, consumer electronics, and healthcare. And we are talking mainly with our customers about co-packaging, data communication, photonic integrated circuits, augmented reality, and smartphone technologies. And to reach all that applications industries, numerical is splitted in different modules, which we like to discuss with you on your needs and on your motivation and vision you have. We have the Ansys numerical FTDD as a fundamental package to design sensors, nanoscale patterns, or coatings. We have the Ansys numerical mode, which is focused on waveguide designs. We have the photonics integrated circuit tool called Ansys numerical interconnect to design photonic integrated circuits provided by saved foundries. We have the Ansys numerical multiphysics looking on electron charge and heating for nanoscale technologies. And we have the so-called Ansys numerical CML compiler, which can provide components, pick components, measured, simulated, and scripted to provide these modules inside for our photonic integrated interconnect for photonic integrated circuits. So if you're looking on photonics landscape, you also will touch specialized challenges. One challenge is the balancing of a component design and the system level for photonic integrated circuits on a multiphysics level. And the ideal solution for such a challenge will be the advanced simulation chain. Needs to respect a precise manufacturing and innovative design techniques inside the software to achieve the synchronization of a single component and the integration and its integration into a photonics system. Also, specialized designs with millions of meshings needing a long and computational extensive simulation, and an ideal solution will be HPC, GPU, and model simplification to decrease the simulation time, but stay accurate and trustful in the simulation results. And last but not least, intellectual property, especially on the nanoscaled level. A lot of new technologies like quantum computing, quantum communication are key drivers and needing to be become protected for your internal intellectual property. And that means software is needing key security features like data encrypting, version control, and watermarking. These challenges on photonics level can be solved by numerical. Looking on balancing on component system level, Ansys numerical optimize component and system performance from integrated component simulation to multiphysics efficiency. That helps to minimize design iterations and reducing your resource wastes and limits performance degradation. Looking on computational extensive simulation, Ansys numerical on the FTDD module is providing GPU capability, and all numerical tools can run on cloud platforms, cloud clusters. That means with help of such GPU, HPC cloud systems, we can speed up the simulation of long or high meshing designs, but keeping the accuracy. That is mandatory. Speed is one side of the medal, but it's keeping the accuracy and the trustful design validation needs to be respected also. And to protect your intellectual property, for sure, Ansys allows secure data formats and is integrated into the IP management, which allows you to control all of these key security keys to prevent you against unauthorized access during the design processes. You are protected, you are fast, you are balanced So, key driver, for example, which technology, as mentioned, quantum technologies is key driver on photonics. For example, looking on quantum communication means protected confidential communication technology to protect against decryption. Very focused on government communication, military communication, police communication, which is needed to synchronize between satellites, ground stations, or needs to be synchronized with fiber couplings. And this technology is needing a kind of, or a lot of photonics devices, like photon sources, phase shifters, beam splitters, resonant filters, Mach-Zehnder interferometers. All that stuff for such a technology can be designed, synchronized, and validated inside our numerical software. And we are very proud to introduce you. Over the next releases, we are planning to release a new feature, which is focused on vertical cavity surface emitting laser designs, so-called voxels, which are mandatory for quantum computing and sensoring. This new feature is planned in the next releases. If you like to become introduced about that new plans, reaching out to MESCO, we are looking forward to discuss with you. What is Ansys Emacs? Now we are switching from the FTDD server to the ray tracing server. We are providing the Ansys Emacs as known as an optical tool, looking on optical performance, optical design. This can be the sequential and non-sequential simulation. Emacs is providing from the first package, the non-sequential simulation, for example, for this trailer analysis. It allows to optimize the optical performance and helps you to understand lens and optomechanical tolerances to the manufacturing processes. Our key industry customers are coming from aerospace and defense, consumer electronics, healthcare, automotive, and they are focused on, for example, endoscopes, telescopes, satellites, cameras, displays, LiDAR, augmented reality glasses, and laser technologies. And we are providing for this applications, for this industry, mainly the Emacs Optics Studio, because it's a trustful optical design tool focused on high precision optical systems. That means looking on Emacs, looking at optical design, there are typical landscape challenges. The first is the accurate simulation for high precision systems. That means we are needing advanced software algorithms combined in a trustful design and analysis tool to deliver accurate optical component and system information that you are knowing that you can trust in this simulation for reality. Also, you are needing to respect that your lens design you have needs to put into an optical mechanical systems. A lens system without an optomechanical tubus is hanging in the air, let me say. And this needs to be synchronized. And for that, a faultless interoperability of multiphysics tool to characterize and to minimize the impact or the effects of that optomechanical systems due to stress, deformation, heating, needs to be detected. Last but not least, the manufacturing. If you're designing an optical lens system, you're needing to respect the tooling rules of your own machines, of your supplier machines. You can design a lens systems, but if you're not reaching the tolerances of the toolings, this system will crash and be stuck on the market. You need to respect and you need to understand how to reach it. And for that, a tool is needed, which is including the manufacturing and assembly parameters for an easy-to-use evaluation to detect design compromises and to ensure during the manufacturing that you keep the high optical performance. To look if a freeform lens design or maybe a lens stack with a lower tolerance is providing the better compromise between costs and performance. And for that, Emacs is providing the solution. Looking on accurate simulation for high precision systems, we are providing measurement tools to validate PSF, MTF, and image simulation, from ray tracing to analysis. Looking on optomechanical requirements to put the lens system inside an optomechanical systems and to validate the systems and against a critical environment. We are allowing a stop analysis provided by the Emacs star module to optimize the optical package performance by respecting structural and thermal effects to stay focused on the optical performance and to give you the chance to reduce the costs on the package. Understanding the package, optimizing the package against performance, and balancing against the costs. This is the star module providing on a multi-physics level. And then manufacturing. So Ansys CMax provides an optimization tool for lens design and optomechanical tolerance analysis. And this capability enables the high quality design on cost-efficient design to avoid expensive delays, failures, and customer unlike. Knowing the performance, knowing the tolerances, you are able to start the button of production. For that, Ansys CMax is split into three different packages. We like to discuss with you against your needs, your motivation to use it. We have the Ansys CMax Pro coming with 4 instances, is providing the complete optical design tools to simulate polarization, ray splitting, scattering, physics-based propagation, spherical, aspherical, freeform lens design. The general usage of optical design is completely covered by the CMax Pro package. If you like to become a little bit more precise in the validation, in the design of, for example, freeform lenses, by providing the true freeform design with more than 2,000 test points for freeform lens design. If you like to make a synchronization to your auto desktop, auto PTC Creo, you can use the Ansys Premium, Ansys CMax Premium. And additionally, this Ansys CMax Premium is come with 8 instances. That means you can work on 8 windows in parallel with one seat. And this is focused on a subsystem level. If you're focused on a full multi-physics design, looking on freeform technologies, looking on thermal effects by structural deformation, coming from heating, coming from absorption, you are using the CMax Enterprise, because the CMax Enterprise releases the complete capability of CMax, coming with a premium, including the star module, and allows complete multi-physics validation, because it's directly linked to Ansys Mechanical, Ansys Fluent, or third-party tool. All that packages we are providing on CMax, and we like to discuss with you against your needs and motivation. Success story on CMax, James Webb Telescope. The James Webb Telescope, which is providing now deep space pictures, high imaging deep space pictures, are designed and validated by the Ansys CMax. Now looking on Ansys SPSM as a lighting tool. This is focused on lighting technologies and system validation. You have a CAD integrated tool. You have a complete virtual laboratory to measure flux, candela, luminous, illuminous. You can set weather conditions, and it's providing decision making. It's focused on automotive, consumer electronics, general lighting. We can design displays. We can validate lidars. We can validate optical sensors. We can make human vision rendering. We can design street lighting, indoor lighting, and we can validate sensor view at night, at day, during fog, during snow. All that stuff we are providing with Ansys SPSM. And also we have here challenges, which are generally, we have to predict a design performance. And this design performance looks like, as an ideal solution, looks like a synchronization of several multi-physics simulation tools for trustful design and quick validation of the designs against external and internal standards like ECE or SAE for automotive. We have the balancing of aesthetic and function, means cost and product quality. An ideal solution is an optical design software offering advanced options for precise optical modeling, providing extensive material libraries inside the software to find the best compromise between functionality and product design. And to look on system tests and visualization, an ideal solution needs to be integrated on a multi-physics simulation to achieve advanced design validations within the virtual edge case scenarios the product has to reach, looking on sun conditions, looking on heat conditions, looking on atmospheric conditions. Should be weather condition, should be sky atmosphere conditions that Modtran is providing to make a visualization like in reality. And also here, Ansys SPSM has a solution. On our optical design, accurate design performance, Ansys SPSM is providing a precise visual modeling, enables improving product accuracy, reducing development costs, saving engineering time, and accelerating the economical time to market by meeting performance and visual product quality. Looking on balancing aesthetics against functionality, Ansys SPSM helps designers to balance technical design conflicts with extensive design and measurements tools included in the software from the first package. For modeling and virtual testing, the advanced multi-physics simulation. And that means SPSM enables the reduction of redesigns, several loops to make a redesign, a revalidation of a failed design, and ensuring both aesthetic and technical goals. And on visualization, Ansys SPSM provides an integrated simulation tool, which is certificated for human vision, respecting the human eye modeling, and finding the connection to ambient conditions to reducing project time on the development and to save re-prototyping costs while design is reached virtually in the edge case scenarios. So that means in Ansys SPSM, we are able to simulate weather conditions, clear sky, fog. We are able to simulate sunlight. That means we are able to separate light distribution on different atmosphere conditions. How a laser beam is propagating through a clear sky or a dense fog atmosphere. And SPSM is able to synchronize, to link to Modran for atmospheric conditions up to 100 kilometers. So, and for that, Ansys SPSM Pro is split into Ansys SPSM Pro for the stray light analysis and the data transfer from ZMAX into SPSM to make a non-sequential unique stray light analysis under ambient conditions after the design in ZMAX and a faultless data transfer from ZMAX to SPSM. We're providing the Ansys SPSM premium design. If you're looking on optical design for especially general lighting, automotive lighting, looking at reflectors, collimators, light guides, pillow optics, we are providing the Ansys premium design tool. Then, if you are looking on a focus on sensor technologies, Ansys SPSM allows the so-called performance and layer check and synchronization of a camera system, LiDAR system under different weather conditions, looking on static, rotation, and 3D scanning of LiDAR systems. We are providing a specialized tool for decision-making on human vision rendering. And for sure, we are providing a so-called Ansys SPSM Enterprise solution, which is including all features, all functionalities as an all-in solution. So looking on thermal desktop is a tool which is focused on fluid and thermal radiation problems. This tool provides quick design evaluation and easy design optimization against a mix of thermal and fluid conditions, mostly focused on space, but also able to set such thermal fluid condition simulation for battery management, thermal optical design, heat exchanger, rocket launch, and fluid tank simulation. So also we have some challenges, thermal management, understanding the complexity of heat transfer and heat control. We have design development challenges against quick design updates against thermal, fluid, and radiation problems. And we have the need on multi-physics level to analyze multiple physics impact on a component and system level to make early on decisions. And here Ansys Thermal Desktop is providing solutions. We have a very easy handling interface. We can simulate the heat transfer. We can simulate thermal radiation and fluid flow. For design development, we are providing the complete built-in measure, includes local mesh control, and helping to identify variable designs by a rapid model changes inside Thermal Desktop for a what-if scenario. And on the multiphysics level, Thermal Desktop can be linked to our Ansys Mechanical, linked to our Fluent and SDK for digital mission engineering. Means, for example, if you have the challenge, you have a satellite, you're needing to know if all the electrical components needing a thermal control system and how that thermal control system works in space, you are using Thermal Desktop. Because with Thermal Desktops, you can predict the satellite behavior during the mission. And this is including typical thermostatic heaters, thermoelectric coolers, insulation and heat pipes. And the benefit of such a tool is that you can ensure virtually that your hardware works within the material limits which you are using from launch to the end of life of such a satellite. This saves money, this saves time on real prototyping, and for sure, very important, it reduces the risk of warranty claims and insurance costs in front of our customers. If you're looking on automation, we are looking on a tool which is providing robust, autonomous, automatically, overnight, robust sensitive analysis. Means if you have a complex design which is needing to reach a specialized product quality, you can use your Ansys Optics link to understand the design space of your design, to optimize the performance, and to know how robust and how sensitive each parameter inside your system is. And this helps you to understand the design parameter of importance, overnight simulation. And this optics links can be linked to Ansys tools, can be linked to third-party tools, can be linked to Excel, SAP, Abacus, Creo. All the simulations are independent in the usage, including optics link, and helping to accelerate the innovation. Faster development means faster time to market, means increased revenue because you have a robust design by a virtual simulation, and faster time to market, unique, robust quality is increasing the revenue for the product. And all these optics links can be covered, can be synchronized with the complete portfolio. CFX, Fluent, HFS, Speos, Numerical, and ZMax. And for example, if you're designing a light guide, automotive light guide for door lighting, cockpit door lighting, you can set the first light guide, you can set the spline, the geometry, the dimensioning of the light guide. You set the first parameters, you take the light guide, you're running an optics link, and optics link automatically overnight finds the best parameters under robust and sensitivity analysis for you, and it's done. This helps to increase the product quality and decrease the development time on critical, long time, on a critical design, which is using a lot of different parameters. And now we are knowing our portfolio, and now what we can do with it. And let's take a quick look, how Ansys multiphysics on a satellite mission is used to design and validate under that space environment. We have our space. We like to start a rocket. We like to bring a satellite for observation into space, and we need to know how it works. You're starting with a nominal design of an optical systems, which can be synchronized, which can be put inside the so-called standardized CubeSat technology. If the nominal optical design is done in ZMax, you put it into the optomechanical packaging, can be covered by discovery. You set the mission of the satellite you have to achieve, or you can set different missions of the satellite you have to achieve. You are knowing your optomechanical system, you're knowing your mission. You can validate the thermal radiation coming from space, hitting the materials, absorbed by the materials, doing the simulation with thermal desktop, understanding how much radiation is absorbed on each material, knowing the thermal radiation, knowing the thermal modeling. You can make an FEM analysis, how this radiation has an effect of deformation or stress on the material, and how that stress has an effect on the optical performance, coming from a nominal design under mission conditions, how it looks like in real life. And if the system is now crashing, you're safe. You are detecting from a conceptual life cycle this failure. You can think about optimization of a mechanical packaging, optimizing of materials to avoid the weakness of a product in real life by a complete virtual loop by Ansys solutions. And this is now a good stage to synchronize or to hand over to Skanway, because Skanway is our very important trustful customer since many years, working with Ansys on such a satellite mission together with Ansys and Mesco. Thanks, Skanway.
Okay, can you hear me?
Yes, we can hear you.
Okay, great. So I try to share my presentation right now. Okay. Oh, so, can you see my screen?
We can see your screen, but this is PDF, yes?
Yes, this is on PDF.
Okay.
It's, I would say,
So,
easier for me and more, I would say, reliable. That's nothing will fail.
okay, so we can see your screen then.
Okay, great. Thank you very much. So, starting from Skanway, we're a Polish company that I would say develops optical systems mostly for space applications. We're, I would say, 9 years old this year. We started as a three-man band in Wrocław, Poland, and starting developing our systems from very small ones up to, I would say, solutions that can provide, I would say, resolutions with very high resolutions for our customers. We're a public company. We went to Polish stock market in 2023 to raise some money for our future developments. We have already sent a few payloads into space, starting from, I would say, our own developments to validate our prototype solutions. But to this topic maybe a bit later. We have basically two, I would say, main product line. One are optical payloads. These are telescopes and cameras for different sizes satellites, ranging from CubeSats with, I don't know, 3 unit size, up to microsatellites with telescopes of apertures up to half a meter right now. Our second our second product are small cameras, small inspection cameras that are more focused on, I would say, inspections and providing, I would say, overall awareness of what's happening with the satellite and the payloads that are part of the satellites. A good example of this product were the maiden launch of Ariane 6 rockets, where Skanway provided two cameras that made the videos and images of fairing separation and CubeSat deployment that ESA later shared with public. We started, I would say, with our R&D developments, but right now we have 6 payloads that are or have been in space. 3 payloads are awaiting launch with our customers, and 10 payloads are under delivery at different stages of developments. I would say our technology is mostly concentrated on developing optomechanical systems, so telescopes, but also as a part of the whole assembly, we're developing cameras as well as thermal management systems. Most of our telescopes currently have active thermal control to keep the operating point around certain temperature, which Ansys and Zimex especially help us to develop and optimize. I would say few examples of the product that developed or are developing the SOP 3U50. This was our first mission that we sent into space in 2023. Basically, our in-orbit demonstrator. This was a small telescope with resolution of about 25 meters per pixel. This was a mission that I would say, founded to test our solution and provide our customers with confidence that we can reach orbit without any problems and provide a functioning payload in small envelope. Last year, we sent into space a bit bigger telescope. It is called SOP 200 and was part of an Eagle Eye mission that we did together with Cryotech Instruments and CBK. It was 1.75 GSD telescope, mostly made of carbon fiber and aluminum. This was also, I would say, a nice piece of optimization that we did on both optical level and mechanical level for this to be as thermal as possible in a very specific environment of the satellite platform. Right now, we're scaling up the solution and developing 450 millimeter aperture telescope that will provide resolutions lower than 1 meter. So we're talking about VHR payloads. And this is a project that we're doing under the supervision of European Space Agency. But this was basically an overview what we are doing and I would say what is the end goal. But let's I would say switch to how we are doing and what steps we are taking for our payloads to function properly in, I would say, challenging environment of space. David, I would say, explained some, I would say, initial points that are, I would say, main points that we have to take under considerations when developing optical systems for space. But there are basically two crucial aspects that we have to address. One is the delivery to space. So the overall launch on the rocket, which is a quite bumpy ride when it comes to mechanical requirements, mechanical stability, because we have to deliver the payload to the orbit without any of the crucial optical parts moving towards each other and without the system breaking the mechanical elements or the optical elements. The second one is operation in orbits. The lack of atmosphere, which is a stabilizing agent for the whole system, high thermal radiative fluxes and conduction through the satellite platform. These are the environment parameters that we have to cope with, especially especially considering the orbital parameters of the system. So another orbit and every 90 minutes. So changing the thermal and radiative environment through the night and day every 45 minutes or so. This is, I would say, great challenge for us to keep the stability of the overall system and how we are designing, how we are calculating. I would say, first and most crucial, I would say, part, apart from the Zmax itself, is the star module and simulations that we are doing on mechanical and thermal parts of the system. So first of all, we're simulating the thermal behavior of the whole payload. We're also using PIT algorithms to develop, let's say, control, control signals for our active thermal control systems to keep the whole payloads around the operational point. We're assembling and collimating the payloads around 20 degrees centigrade in our laboratory, and we try to keep it similar in orbit. But the cornerstone that allows us to control the temperature are the simulations to know where what material has to be how heated and use those control signals in the system. Also, Zemax helps us to assess where we have to place temperature probes and also heating elements. One of the, I would say, apart from Zemax, but in the mechanical module of the Ansys we are using model analysis to optimize the structure for the launch itself of the rocket. Most of the launch vehicles require us to have the lowest natural frequency of the system above 120 Hertz, and Zemax allows us to analyze it and optimize the structure for having those eigenfrequencies or on, I would say, safe level. Next is random vibrations. As I said, rocket launches are bumpy rides, and we have to be certain that during the whole process, nothing breaks, and random vibration analysis allows us to assess if our, I would say, current design is on the safe side from the mechanical stresses. If no, we try to iterate and develop a structure that will have no problems when it comes to rocket launches. Static structural analysis allows us to also analyze the whole structure when it comes to certain G values that are I would say that comes into play when we're considering rocket launches. There is also the acceleration of the rocket is quite significant, and this has to be taken into account when designing especially large telescopes with large primary mirrors. Static structural analysis from Zemax, I'd say we have a lot of large optical elements and also mechanical elements in our designs, and we have to ensure that they won't break under stress induced by rocket launch or temperatures that are varying during in orbit operation. That's why we try to simulate the static conditions and see if any stresses don't exceed the I would say safety margins. For example, in lens assemblies, if the lenses will survive the day and night during orbit. One of the biggest, I would say, hurdles that we have to, I'd say, address when designing optical assemblies. Optical telescopes that work in orbital conditions are transient temperatures, either from radiation from Earth and Sun, or I would say radiating heat from the payload when considering the orbital night, or from the satellite platform itself. We have to take those, I would say, temperature deviations and deformations of the structure into account, because in larger assemblies we have to keep the position and orientation tolerances of individual elements within very small margin, like in an RC telescope designed for 450 millimeter telescope. The secondary mirror has to be within few micrometers tolerance in respect to the primary mirror, and the overall length of the telescope is around half a meter. So keeping those tolerances are quite tough, and simulations in transient thermal conditions help us optimize the design to keep those tolerances together with the PIT controller that provides us signals for active thermal control. So this is, I would say, great help for us when providing the control signals for the actual heaters and designing the exact positions of the heating elements and temperature probes. Also, we're using the star module to analyze how the individual optical elements are deformed when thermal characteristics of the telescopes are taken into account. So we're modeling the primary optical system, then using the thermal simulations and mechanical simulations, we model the deformations of the optical elements, and then back at the Zmax, we're assessing the performance of the optical system to know what to expect in given thermal conditions and how to counter it, either by using active thermal control, placing some heat pipes on certain elements, or changing the material and structure overall to get the right performance under right conditions. This is a visualization of one of our projects. The deformed surfaces are then thrown back into Zmax to analyze the actually end performance of the whole system. I know I talked a bit chaotic sometimes, but the time is, I'd say, very stringent today. If you have any more questions on how we use Ansys tools or how we develop our optical systems for use in space applications, feel free to contact me or anyone else from my company. Thank you very much.
Thank you very much for your presentation, and we go back to David.
Thanks, Michael, also from my side, also from Ansys side, for that awesome presentation. I guess looking on these slides, how using Ansys software solutions is directly proving all my comments at the beginning, looking on the challenges as an optical engineer, as a photonics engineer. It's not only about designing an optical system. It's to take care about that optical system in the environment where it has to work. And the multi-physics understanding from optics to structural analysis, thermal analysis, the understanding of fluid simulation, mechanical simulation as an optical engineer is mandatory to push such high quality products like Skanway is providing in the critical environment of space technologies, and also looking on not only the technology in space, respecting that these products on a system level will survive the launch of the rocket. And for that, the usage of software is mandatory to reduce the risk and to increase or to prove the quality your company promise in front of the customer or government department to provide such high precise systems. Thanks, Skanway, for that presentation. And from Ansys side, we are very proud to work with you on such outcomes. Now let's go back to my presentation. As you maybe remember, we are now going on the providing of such solutions, how we are able to provide such solutions, how you will be able to start learning on these solutions. And for that, please let me know if you can see my
yes, we can.
Okay.
Yes, we see your screen.
And the startup program you can see?
Yes, Ansys startup program.
Great, thanks, Marcelina. Generally, to the audience, Ansys software solutions are floating solutions. That means we are not providing any dongle technologies. Our software solutions for you, independently if it is commercial, startup, academics, are provided on a so-called Ansys license manager. And these floating licenses, you can purchase as a yearly lease or as a one-time perpetual investment. Each license having updates, having technical support, which is called the tax, the annual tax on the software solutions, which is giving you the access, asking MESCO for the usage, optimizing the usage or critical simulations, tasks you can't solve, reaching out to the technical support in North MESCO. And we are providing 2 times per year, at least 2 times per year, updates of our software solutions on new releases or 1 or 2, matching with the needs and pains of our customers working on the development of our software solutions. So this is very general. Floating license, you can lease it, you can buy it for your own. So, and in case that you are maybe starting a new company, or in case that you're working on a non-profit project on a research center, or you're talking about teaching on universities, on schools, Ansys is providing several programs for such kind of usage. We will start with the Ansys startup program. Maybe one of you are thinking about a spin-off, coming from university, starting a commercial business, coming from a research design which proves and brings value for the human mankind. You are starting your company, you like to place a new product on the market, unique product, and you need to stay fast and accurate and trustful for the design. And for that, we are providing the so-called Ansys startup program. Young companies which are starting business. That means our startup program has several benefits. At first, we reduce the cost to a minimum, respecting the age and the grants you catched. We are inviting you to the complete Ansys ecosystem. We are working together with you as a young startup to place you on the market and to provide all technical support and software updates to help you starting your business. You will have access not only to a single software solutions. We will provide complete bundles focused on industry fields. And this is helping you to reduce the risk of a young company by discounted software investment, and is helping you to speed up the time to market, because all our software solutions on a startup program including HPC packets. That means you can directly push the button of performance and having access to a complete bundle to reach the industry field. Reaching out to Mesco, if you will become interested and if you like to become introduced in some details. Generally, if you're talking about a startup program, there's a kind of eligibility criteria. Ansys and Mesco will discuss with you. If all that eligibility criteria are given, Ansys can approve the access for a young company to our Ansys startup program. This Ansys startup program can run up to 3 years and is providing lease bundles. If you are a private held company, maybe a spin-off from university, spin-off of research, you are not a pre-existing company at Ansys. You are not older than 10 years on the funding of your company. Your revenue is less than $5 million per year. You have the will to cooperate on the full multiphysics scale with Ansys solutions, and you have the will to make marketing activities together with Ansys, together with Mesco, showing you on our networking, showing us on your networking, to validate and to prove your success, to show your success as a startup company with the support of Ansys. You can have access to the startup program. What does it mean? With the startup program, we are providing specific physics-based bundles. And all the bundles are providing high-performance computing. These bundles are focused on structure and fluids. We have a specialized bundle for electromagnetics, high frequency. We have a specialized package on embedded software coding. We have a specialized product on semiconductor, analog and digital. And we have a so-called Ansys startup program digital for digital missions, looking on SDK, for example. And for sure, that's why we are showing it. We have a startup bundle for optics and photonics. If you're now looking on the challenges, but also on the solution and the value of your new product you like to start as a startup company, Ansys can help you to start your business and to reduce your risk by providing a complete package inside optics and photonics. That means you will have access to the full usage of numerical. Means on the nanoscale level, you have 2 seats of the numerical enterprise, which is providing the complete package we have introduced before. You can make FDD simulation, you can make mode simulation, you can make multiphysics simulation, you can make interconnect photonic integrated circuit simulation for 2 seats. This includes so-called numerical HPC packages to use GPU, to use HPC performance. We are providing 2 seats of ZMX Enterprise. That means 2 ZMX Enterprise, including the multiphysics star module, which is, for example, mandatory for a company like Skanway on a commercial level to validate thermal effects on optical performance. You have 2 full access seats of ZMX, providing all features which are released. And last but not least, 2 SPSM Enterprise. That means 2 SPSM Enterprise, which allows you to make optical design, to validate camera and LiDAR systems, to make visualization of products and customer-like under GPU usage. Because for the Ansys SPSM Enterprise, we are providing so-called Ansys HPC packs, which are specialized for SPSM to start GPU. to allow you multi-physics simulation. Full package on optics and photonics. If you have a product, maybe in 3 years, there's a new product pane, engineering pane. Maybe you have to switch from an optical design to a photonics design. For example, maybe you have to adapt in your product a meta lens inside the optical system, or needing to provide an optical coating which is not existing. Or maybe you have an optical systems and you need to validate the system under critical ambient conditions which are not respected in the first design loops. Or maybe you have a customer electronics product which needs to be visualized and ask customers, what do you like that product? Or you use it for your marketing. All that stuff from the first nanoscale photon to a complete system rendering, real physics-based rendering. It's not a normal pure rendering. It's a real physics-based rendering to validate weakness of your products. You are able to use. And to optimize the complete loop of that bundle, we are providing the so-called Ansys Discovery, which is a multi-physics CAD tool. A CAD tool to design your product, to design your component, but also allows thermal and fluid simulation on a conceptual level. Directly sees the effect of a conceptual design against thermal and structural stress. Each software solution is for 2 seats. You have 2 numerical, 2 ZMAX, 2 spheres. And you can start with all technologies Ansys is providing to cross your borders and to close technical gaps on a starter bundle. This starter bundle is focused on a commercial support, especially young companies. We also have the Ansys academics. We are supporting universities, research centers on a specialized package for non-profit research and education. Because our understanding of the academics program is that students of today will be the engineers of tomorrow. And the usage and the need of simulation skills is increasing massively over the next years. So we need to touch the students, helping students to understand their student level, helping to understand the industry and the theoretical fundaments by supporting it with software solutions. And also we are knowing that research centers, which are also covered on that academics panel, are the spearhead of research and development of new products. Many spin-offs coming from research, testing, playing with software solutions, finding technical solutions which are not existing. Research centers, universities are the spearhead of new products. And that's why we have a focus on academics, providing a specialized package for this non-profit teaching and research centers. Because at this moment, around about 60% of all engineers coming from or working for our best-in-class companies in simulation, using simulation, have to touch an optical simulation, have to touch a structural simulation, have to touch a CAD system, CAD design tool. 60% for all engineers using software. In the past, in 2025, roundabout, 1 of 20 engineers are focused on simulation. In 2020, 1 of 5 engineers using or needed to work on simulation. And in the future, we're expecting that roundabout all engineers working on a product design, working on product optimization, will need simulation. That means the need of simulation will increase massively over the next years. And students of today needing to become skilled, needing to become taught on simulation because it's mandatory. And coming skilled is providing job options. So, and this depends not only to one industry field. This depends to aerospace and defense, transportation, high-tech technologies, healthcare, industrial equipment, energy and construction. Worldwide, everywhere the use of simulation is growing massively. And our partners on academics level providing these fundamentals to their students. Because looking on the curriculum embedment, you can use the Ansys academics program for education. Or to the right side for the research. For example, by integrating student teams on a specialized real-life project, using the software to design a sports car and then test it on the track against each other in the student program. Because we are providing this Ansys academic program, we are providing student, educators, and research access to all that industrial leading simulation we discussed before. And it's restricted to non-profit education and researchers. And for sure, such simulation, understanding and usage of simulation is helping universities that students stay focused. Students software helps students to understand the theoretical lessons before by resimulation, because software can help to keep students motivated, to stay focused on situation and to understand the lessons by recapitulating on a software or by a software. So at this moment, we have more than 2,600 institutions in more than 91 countries providing on an academics level. More than 3.8 million students made a download of free student licenses. I will show to all students at the audience, I will show you where you can have access on it. We are supporting more than around about 2,000, you can say, at this moment, you can say around about 2,000 student team partners, where student teams designing a product and fighting each other on the university level, which is the best student team providing the best product portfolio. And we have more than 600 innovation courses, which are free for students on a research and academics, on a general academics level, to understand the usage and to become taught on the usage. Looking on the academics, optics, and looking on the academics for numerical. At this moment, it's split. We not have an optics photonics academics bundle. We need to discuss with you your needs on the research, on the teaching level. How much teaching licenses you are needing, how much research tasks you are needing. But at this moment, it's split on optics and photonics. If a university or research center is needing an optic design tool, lighting tool, or system tool, we are providing the Ansys Optics by Siemens and SPSM for the so-called research optics and teaching optics. Independently, if you're talking about research and teaching, both are included. And looking on a multiphysics level, the highest value comes from our so-called multiphysics campus. Because with multiphysics campus, we are providing the Siemens, the SPSM, but also all needed software solutions, for example, to look on such workflows Skanway was presenting. Because it's also the full access to structural, fluid, thermal, electronics, and semiconductor simulation, including HPC packs. On the photonics level, if you can know nanoscale designs, quantum technologies, co-packaging, waveguides, photonic integrated circuits, quantum technologies, emitter design, sensor design. We are providing the so-called FTDD, the numerical research and teaching, similar to the optics portfolio. There's a specialized package which is limited to the FTDD, which is the fundamental tool of numerical to start teaching, to start research on nanoscale designs. But then we have the numerical research and teaching, which is providing all modules we have introduced, including FTDD, mode, multiphysics, interconnect, and compiler. And very interesting, also the optics link. That means if you have a complex photonics design with 1 million of meshings and thousands of parameters, you're not able to find a hand-on solution. You are able to use directly optics link from the research package of numerical, from the teaching package of numerical, for product or for robust product optimization. Some examples. For example, how students becoming industry innovators. For example, we have the University of Bath. They use the academics program to design the artificial heart. That means software, academic software solution provided by Ansys was helping to explore different possibilities and ideas quickly without needing to physically create each prototype. That means simulation was helping to validate several design concepts and to validate each other before starting the prototype. Quick and fast and trustful. Also, the University of Arizona. It's a university which used the academics program, or is maybe using the academics program for new generation of telescope optics. They are using the optics academics bundle to design and testing next generation of telescope optics. Or the Coburg University of Applied Sciences. They made an investment of software solutions to look on computational fluid dynamics with our software Fluent, which bridge the theoretical learning with practical application, something I mentioned before. Theory, practice, understanding by software solutions. This are the key drivers here. So, all students here at the audience, if you are a student of a registered university in cooperation with Ansys MESCO, you are able to download free students licenses. For example, also for SPSM. You can search for the Ansys student free product download, and this Ansys student download for free as a student is providing the Ansys SPSM. If you're looking on ZMAX optical design, you can start since this year a student download for Ansys ZMAX, limited to the sequential mode, but you can test, you can play for your student projects, for your documentation, for your bachelor or master thesis. You can use the ZMAX for a free download. Your university needs to be a registered account at Ansys and MESCO, and then you will be able to download. Feel free to visit ansys.com students, and then you will guide to the web page that I will show you afterwards in the next slides again. So, we are providing Ansys startup, we are providing academics, we are providing commercial licenses for commercial usage. How you can find more information. Your first contact for more information and questions is MESCO. Reaching out to them, tell them your question, providing your information, and then MESCO will jump in and is providing the support related, or will give the response related to your communication. In case that MESCO is not able to solve because it's a little bit more complex, or it's a kind of roadmap of a simulation development, they will reach out to us. Maybe they will reach out to me, and from Ansys side, we will provide additional information to give you a response. Also, we are providing the so-called Ansys Learning Hub Campus. It's a virtual campus to learn on a self-paced pace the usage of each kind of software we have. Because this campus is split on different industry fields. For example, we have the optics and photonics, which is now put together. And within that campus license or Ansys Learning Hub, on click on optics, you will have complete training sessions, learning and understanding and optimizing the usage of SPSM. From a pure understanding what the software is doing, to the interface understanding, to clear, precise feature designs, like in SPSM freeform lens design, like in ZMAX, multiphysics validation, or numerical, the multiphysics validation of quantum efficiency of solar cells. All our customers can have access on it. Reaching out to MESCO, asking for it, they will provide to you a proposal how to use it. If you're a new engineer, if you have new engineers, if you like to become introduced into that new simulation tools, you like to understand, reaching out to MESCO, ask for access to the Ansys Learning Hub. And here we are providing self-paced training sessions. Very interesting for you is also the so-called Ansys Application Gallery. This Ansys Application Gallery is providing a specialized filter for you. If you're trying to find out if Ansys have a solution, if you need to design a specialized technology or you need to solve a project, you can go on to to optics.ansys.com. And this application gallery will provide you a search bar or a filter against application industry. And you can set each filter, and this application gallery will bring you introduction, demo material, workflows, how to solve it. For example, if you click on healthcare, again on the filter of industries, you will have demo sessions, introductions, how, for example, design endoscopes from numerical to Simex to SPEOS, meta lens design, optical design, and validation of an endoscope image into the V with SPEOS. Or human eye modeling. We like to see how glasses or contact lenses has an effect on the retina image. All that stuff we are providing on the application gallery. And feel free to look and to understand and to ask if you're needing something. For fundamental information about Simex, SPEOS, numerical, feel free to go on ansys.com products optics. On that webpage, you will find the trial request. You will find some fundamental information, but it will be better to reach out to MESCO because in that case, maybe it's much quicker to give you access. And if you're now on the Ansys academics level, from university, school side, or research side, you're interested in details about as researcher, as educator, or students, you can take a look on Ansys.com academic about some details of our program. So, and the same for the students, as mentioned, we are providing free student licenses for SPEOS, for Simex. I have to apologize, not to follow America, but on a ray tracing server, we are providing it. You can check at ansys.com students the access to that free student software and the downloads of it. Okay, great. So, and if you now like to stay focused, and if you like to follow Ansys in our travel through optics and photonics, and to reach every day new limits, and to cross every day existing borders on the field of optics and photonics, you will become updated automatically by following us on LinkedIn. You will be invited to webinars. You will be updated about product releases, demo materials, simulation features on Simex, SPEOS, and numerical. And for sure, you can have the invitation if you're introducing about the new releases and what is included. So feel free, it's for free to join us via LinkedIn. And then we have a nice easy communication line. So that is the main slide and the last slide for today, because we have started with a short introduction of myself, a short introduction of MESCO. And I introduced at the beginning that the job of MESCO and Ansys is and will be that our customers, our partners, our universities, our research centers, creating positive business outcome with our solution. And I'm staying close to MESCO, with a complete MESCO team, to find that goals for you. In case that it's a critical situation, the technology is not provided, the technology is not working, feel free to reach out to MESCO, because the complete MESCO team and me, we care about your success. We like to make you faster on the engineering by providing portless simulation tools, to simulation chains, by providing simulation speed to decrease the time of simulation. We like to give you access to software solutions. And we like to stay in touch with you, in communication with you, to close with you technical gaps you have, which allows you to cross borders. That's why we are reaching out to you. We like to discuss with you. What is your job today? What is your vision for today? Where it's stuck for today? Where you see a gap for tomorrow? To keep you up to date and leading on your industry for our solutions. And for sure, last but not least, if all that rules, outcomes are set, officers, chief officers, business outcomes. Okay, so and that's the goal. And for that, we can have the question answering round now, because that was the last slide. Sorry, my computer was crashing for some seconds. I don't know why, but it was the last slide for today. And now maybe we can have our question and answering round. Okay. Hello?
We actually have two questions.
Okay.
The first one is for you, David. And it's what set of numerical tools will be the best for simulate femtosecond laser structuring of nanocomposites?
On a photonic integrated level, we can simulate by the quantum interconnect such components, but looking on the design of this components, we have to discuss with the client the usage, okay? To take a look how our portfolio needs to be mixed to reach as much as possible on the goals.
Okay, thanks. And we have one more question to Michał this time. Do you verify your analysis against test data? If yes, then how?
Against what?
Test data.
Is it written in the chat? Because it was not understandable.
It's the question, the answer section.
Let me check in the chat. I don't see the chat.
I copy it right now.
Okay. Against test, do you verify your analysis against test data? If yes, then how? What does it
Okay.
mean, test data?
To-
Because generally, for sure, if you have a product design, let's say focused on automotive lighting, okay? If you have an automotive lighting system, that's plates in a car and lids. So you need to validate that optical performance against standards. So that means there's a regulation in Europe, how, for example, a low beam needs to be in performance to release that system, to release that headlight for driving. So, and in SPSM, we can test that standards directly on the sensor. We take the sensor, we take the validation or the regulation on the sensor, and SPSM is telling the engineer, this light distribution is okay or not okay. And if it is not okay, it shows you where it is not okay, to take a look from where in the optical system the light is coming, touching that sensor, to reduce the limit, to reduce the flux or to increase the flux. And also, then the next level will be, for example, to test headlight systems. We are connecting our spheres to the so-called AVX tool. AVX tool for example, the assurance validation in China or in North America against IIHS or CCC or Chiasi, CNCAP. That means we are testing the complete systems virtually on the street, simulating the test scenarios to take a look if this system is reaching the minimum of regulation and is reaching the assurance rating on the continents, the continental assurance rate. And if you are a little bit, if you become catching maybe some more information, what kind of analysis and what kind of tests you're asking in the chat. We can make it a little bit more precisely in a follow-up meeting. Because analysis and testing, the workflow depends on the industry field you have. And it's a complete different discussion if you're talking about a satellite observation system or automotive lighting system.
I can answer, I would say, the question on how we're currently doing it, because I'd say the simulated performance of the, I'd say, our payloads, our telescopes that we get from Ansys product is its mechanical, thermal, and ZMAX, so optical and star module in general, that we, I would say, use to simulate, I would say, the aberrations that are caused by, I would say, temperature variations. We use I would say this together with I'd say tests that we perform in thermal vacuum chamber. Basically, we're using those environmental testing to validate our simulation data. And on the, I would say, highest tier of testing, we're doing something that is called live TVAC testing. So basically, we're putting our payloads into a thermal vacuum chambers. We simulate some thermal conditions through, I would say, hot, cold walls of the thermal vacuum chambers, measure the temperatures on the telescope structure, feed this to Ansys, see how it correlates, and also we use some, I would say, wavefront measuring devices like Shack-Hartman sensor to see how the light passing through the telescope behaves in real life, and compare it to the model to look if it behaves the same as the simulated one.
Thank you for the answer question.
Thanks, Michael.
I actually don't see anything else in the chat or in a Q&A session. So I would like to thank you, David, to you for the presentation which you prepared and for your engagement during that webinar. Also, I would like to thank Michał for his part of the presentation and for showing
Thank you for the
us
opportunity.
the real case study. There is no more questions. Then enjoy the rest of your day, and we will meet tomorrow again on the numerical live demo, and we start at 11 again. So thank you and have a great day.
Thanks, Marcelina. Stay tuned. Stay
Thank you.
focused on Thursday, Friday, and on May 13th, because then you will have the demos on numerical, on ZMAX, on SPEOS, with help of the understanding of our introduction for today. Stay tuned. Will be attractive and interesting for you. Okay? And it was my pleasure to be the chosen speaker for today's webinar. And please stay all fit and successful for today. Bye-bye.
Bye-bye.
Thank you. Bye-bye.